about the different solution for a particular problem. And in this case, we have considered one problem, that is to check a given number whether it is prime or not. And I have given you 4 different solutions for that particular problem. And I have already considered shown you that one particular practical problem to reach from Calcutta to Delhi, there are different solutions, 4 different solutions. And among those solutions, one is time bound, another is, you can say, money or cost bound. Same for this prime number problem. If you see that there is a 4 different solutions, and which one is more, you can say, which one is more important parameter to judge whether a given solution is best or good. The best parameter is the time or time complexity. So we try to understand among these 4 solutions for a particular given number, whether it is prime or not, among these 4 solutions, which one is the best with respect to time complexity, not space complexity. Why I am telling you that? See, there is one simple thing, that if time and cost, there is 2 things, then for this particular problem, or generally in all the problems, I will show you later that how this time complexity and space complexity, they are related. Actually, there is a trade-off between time complexity and space complexity. What is that? If you are taking less time, see, in this case, you are taking less time, your space complexity will be increased, your cost will be increased. Similarly, in this case, if you are try to minimize the space or cost, your time will be increased. So there is always a trade-off between space complexity and time complexity. For this type of solutions, for a particular prime number, you see, if you try to solve the problem in less time, then you will see that you have to use more variables. It means you need more data to store the values. Okay, it means it is increasing the space. Clear? So there is always, remember, there is always a trade-off between space and space and time. Okay, and it has been seen that when we try to minimize the time, automatically the space will be increased, and if we try to minimize the space, automatically the time will be increased. So we try to optimize these 2 things. That is a different thing. We sometimes try to optimize these 2 things. So that's why in this case, if I want to optimize these 2 things, then I will definitely prefer this solution, which will be not that much costly and also not that much time consuming. So we will try to optimize this. But if again, I am telling you that in case of coding or your data structure or algorithm or for solution for a particular problem, we always try to look after the time complexity, which is more important. I have already told why, because nowadays the RAM size is huge. I have one server machine for my machine learning operations, which is already installed in my department, that has 128 GB RAM. So you can understand, so the space is not that much a bound nowadays, but time is still a very, very important. Okay, so now try to understand among this solution, among this 4 solution, which one is taking less time. So let us take one example. Suppose my given number n is 70. I have given the number n equal to 70. So I want to check whether this number is prime or not. So you know the answer is it is not a prime number. Sorry, it is a prime number. 17 is a prime number. Now just try to check how many times this for loop will be executed. Means how many times I am repeating this thing. For loop means I am repeating this checking. whether divisible or not. I'm checking this thing again and again. So how many times? For this first solution, how many times this loop will execute? It will start from 1, it will go up to n. So we can say it will run up to 17 times. Clear? So if my given number is 111, I have to run this for loop 111 times. Clear? Now move to the second solution. For the second solution, since I have considered it will not be divisible by 2 to n minus 1, it means I have already reduced the time or repetition by the value 2. See, I'm not going to check 1 and n. Clear? So it means now for this particular for loop or for this particular solution, my repetition time is 15. Now move to this one. Now it is from 2 to n by 2. Now what is the value of n by 2? Since it is 17, so I am going to check up to, so it is integer division, so it will go for up to 8. So 2 to 8 means 2, 3, 4, 5, 6, 7, less than 8. So up to 7. So 6 times. So the third solution will take or repeat the for loop only 6 times. See, from 16 it is now 6. From 15 now it is 6. Now try to check this one, the final solution. So here I am considering less than equal to square root of n. Again it will take the integer value. So 17, it means it will go up to 4, correct? Square root of 17 means 4 point something. So I'm considering up to 4. Okay, so 2, 3, 4. So how many values this loop will execute? It will execute only 3 times. So now you can easily understand. So this is only for a value 17. If a huge prime number, then you can easily understand how the algorithms or the solution is reducing the time complexity. So among these 4 algorithms, this one will be considered as the best time complexity with respect to time. Because for a small value n equal to 17, it is only repeating the same thing. Repeating the same thing means n modular division n. This is the operation actually you are checking, whether divisible or not. So it is only checking 3 times. So this one is the easiest solution, or you can say the best solution with respect to time complexity. So this is one very simple example to understand that for a particular problem, there may be different solutions, but which one is best or which one is good, that will be decided on the basis of 2 parameters, time complexity and space complexity. But among these 2, time complexity or time, we consider the time complexity is the very important parameter, because nowadays space have not that much bound. So we consider time complexity as the best parameter to choose to decide whether a given solution is good or bad. Okay. Now among these 4 solutions, this one, the 4th one, where I am going to check up to square root of that number, is giving us the best solution. Okay. So this is all about how to consider whether your algorithm or whether your solution is good or not. And you will see that there are different sorting techniques. I hope you have heard there are different sorting techniques. Even there are different searching technique also. Why there are different searching technique? Because we know searching means we have to search a particular element. Then why there are different solution? Again, the reason is there are different solution because we have to minimize some parameter, either time or space. That's why there are different solution. And I hope you know that there are two different searching or three different searching. One is the normal searching technique, which is called linear or sequential search, linear or sometimes called sequential search. Okay, there is another searching which is less time consuming, which is called binary search. But there is but this is very means a vital question, that is it true that binary search required less time? But if you think properly or deeply, you will see that in case of binary search, your data must be in sorted order. So if your data is not in sorted order, if you want to try binary search, then first you have to convert the unsorted data into sorted order. Then only you can perform the binary search. So how we can say that binary search is taking less time? Because it is not applicable at all for an unsorted order. So it means for binary search, we need sorting. So you must improve the time complexity of sorting. So it means practically or deeply, binary search is not less time consuming, but if the data is sorted, it will definitely give you searching in a less time. There is another interesting searching which is based on this binary search. Means in this searching again we require the array in sorted order, and this is called interpolation search. Okay, this you can say one advanced version of binary search. Okay, similarly in case of sorting, there are different sorting techniques. You have heard bubble sort, the basic sorting, but this is not the best. There is selection sort, this is, and then there is insertion sort, then there is quick sort, then there is merge sort. So there are different solutions for a particular problem, sorting. But among this sorting, I will show you the most practical one is this one, selection sort. This one is practical, but it is not good with respect to time complexity, but this is more practical solution. Okay, so for a particular problem, there may be different solutions, but we have to decide, or we have to understand which one is the best with respect to time complexity or space complexity. It means, suppose you are going to give, suppose you have given one solution for a particular problem, and you are claiming that your solution is best, then it must be measured with respect to time complexity and space complexity. If your algorithm, if your solution is good with respect to time and space complexity, then you can say that, or you can claim that you have given a better solution. Okay. Any query? Hello.
मुस्लिम क्रिश्चियन रिलीजन की पुलिस बना लिया तो
Subham, if you have any query, you can ask me, or you should mute yourself. Shubham Tiwari, are you there? Thank you, Subham. Okay, now if you have any query up to this, you can ask me, or I will move forward. If you have any query, you can unmute yourself and you can ask.
Sir, in characteristic of algorithm, what is effectiveness? Can you explain again?
Yeah. See, when I am writing some algorithm, I will write some steps. I will write some sequence of steps. So each and every step should have some effect. Suppose I am writing some steps which have no effect on the algorithm, or which have no not forwarding your solution, or which is not at all useful in your. Suppose I want to check whether a given number is even or odd. And in that algorithm, I am adding n. Suppose this is the given number n, and I'm adding n with another number, say 5. Suppose I have used one step, this one. Is this step any effect on the algorithm? No. So that's why I'm telling that each and every step should have some effect on the algorithm or on the solution. If you are using some step which has no meaning, which has no use, then it is not effective algorithm. Am I clear now?
Yes, sir.
Okay. So if you are checking whether a given number is even or odd, you should check n modular division 2. No need to add some value with your n. So this step is having no effect on your algorithm. So that's why I'm saying your algorithm is not effective. You have used some steps which has no effect on the algorithm, no use on the in this particular solution. So that's why I'm telling you that your algorithm must be effective. Each and every step must have some output, or it should carry your problem towards the solution. That is called the effectiveness. Okay. Okay. Now, if you have no query, so I have already discussed what is algorithm, what should be the characteristic of the algorithm, and how you will decide whether your algorithm is good or bad. Now I will say different types of algorithm. That is very interesting. What are the different types? You can write your algorithm. Okay. So the first one, that is the you can say the preliminary or the basic idea of solving a problem, that is called brute force. Okay. Now, brute force type of algorithm, actually what is happening in case of brute force type of algorithm, here we are going to check each and every data. Each and every data will be checked. Okay. Just like bubble sort. If you know the bubble sort algorithm, you know that in case of bubble sort, we are going to compare the adjacent elements, whether it is in order or not. So it means to sort the array, we have to compare each and every element. Similarly, suppose linear search. So what is the meaning of linear search? What I am doing in linear search, I have a given element X and I want to check whether it is present in my array or not. So it means I will compare my X with each and every element present in the array, whether it is matching or not. So it means I am using every element in my algorithm. So this type of algorithm is called brute force algorithm. So the meaning of brute force is where I am using the normal idea. Normal idea means how to check whether a given number is there or not. I will compare or I will search each and every element. If my element is matched, then I will say yes, it is present. If not matched, I will say it is not present. So this is called the normal brute force algorithm. Now, there is an alternative for this brute force algorithm where instead of comparing with each and every element, we will skip some elements. Okay, and that algorithm is called divide and conquer. Divide and conquer algorithm. And what is the simple example of this divide and conquer? If you have heard or know binary search, then you know that in case of binary search, first we will compare with the middle element. If my element X is greater than this middle element, I will go in this side. If my element is less than this middle element, I will go into this side. It means I am not comparing my X with each and every element. I am skipping some elements. It means I am dividing my problem into smaller size, and it means I am not using or not comparing with each and every element. That's why it is different from brute force. And why it is called divide and conquer? Because my whole problem is divided into sub-problem. Remember, These two subproblems having no relation, they are independent. There is no dependency between these two subproblems. Clear? Then it will be called divide and conquer. Now, if there is some relation between these two subproblems, then it will be called dynamic programming. So another type of algorithm. So what is dynamic programming? If you want to define dynamic programming, so dynamic programming. So what is the meaning of dynamic programming? In dynamic programming, there is a two different parts. I have divided my whole problem. This is my whole problem. I have divided into two smaller parts, but there is some relation or dependency between these two parts. But in case of divide and conquer, there is no relation, no dependency between these two parts. But in dynamic programming, there is a dependency. Some past value will be required to both the cases. That's why it means there is some dependency. Then it is called dynamic programming. So perfect example of dynamic programming is Fibonacci series in recursive form. Now, if you see the Fibonacci series in recursive form, I hope you know the function. So suppose I want to calculate Fibonacci series, say value number, say fifth value of the Fibonacci series. Then what I will call? I will call Fibonacci series 4 and then Fibonacci series 3. I'm calling it recursively. Then 4 will call Fibonacci series 3 and Fibonacci series 2. Then 3 will call Fibonacci series 2 and then Fibonacci series 1. See, this 2 is present here as well as here. So if I calculate the Fibonacci series value of 2, then that will be used in both these parts. These two different parts require same value, same past value is required. So it means this is a kind of dynamic programming. So the dynamic programming and divide and conquer having similar structure, but only difference is in case of dynamic programming, there is a interrelation or dependency based on some past value. But in case of divide and conquer, there is no interdependency. They are independent. They will solve the problem independently. And finally, if we see the total solution, it will be my final solution. Okay. So these are the three different types. There are more types. Now, there is another type we can say recursive. So you will easily understand what is the meaning of recursive algorithm. It means we are calling the function again and again. That's called the recursive. So factorial calculation in recursive way. This is a perfect example of recursive algorithm. Okay. Now there is another type which is called greedy algorithm. This is very important algorithm. This type of greedy algorithm is actually used for optimization. If I want to optimize something, if I have a problem to optimize my time, traveling salesman problem, knapsack problem, okay, then graph traversing problem, all are based on optimization. What is the meaning of optimization? I have to select, I'm giving one example. Suppose, let us suppose, so these are different, you can say these are different path. These are different path. They are interconnected. These are different path. They are interconnected. This is my source. I have to reach from there to there. Suppose this is Calcutta and I have to reach Delhi. Okay. I can reach Delhi via this route, or I can reach Delhi via this route, or I can reach Delhi via this route. So there are different possible routes. Among this route, which one is minimum or optimized route with respect to time or with respect to space or cost? Okay, clear. There are different. Suppose if I go, say if I go, suppose I have I am going by flight, and my flight Kolkata to Delhi will be halted first at say Bhubaneswar, then it will go to say another one say Bhopal, then it will go to Delhi. And there is another route from Calcutta. I will go first into Mumbai, then from Mumbai to say Gujarat or say any station, then it will reach to Delhi. So which one will take less time? Okay, so that is called the optimization. This optimization technique is very much useful in our internet. In our internet, there are different possible paths. So these are the nodes or servers. They are connected. So how I reach a particular server, there are different paths. That's why when you call someone else, you will hear the sound beep, beep, beep. It means it is trying to connect with different intermediate servers to reach the destination. Okay, so this in this type of algorithm, we will try to solve, or we will try to measure the local minimum or optimized solution. Then it will be converted into global minima or global optimization. And this type of algorithms are called greedy algorithms. Okay, there is another interesting algorithm which is called backtracking algorithm, and this type of backtracking algorithm is used in our chess game, or in tic-tac-toe problem. In this type of problems, we use this backtracking. Why? What is the meaning of this backtracking? Suppose in chess game, I want to move into this state. These are my initial steps, and after reaching or moving into this initial step, I see that I can lose. I can lose my say. I can lose my horse, or I can lose my king. So I will backtrack. I will backtrack and then go for another solution. Then I will go for another solution. Again, I will see whether it will give me some good solution or not. Otherwise, I will again backtrack. Okay, and then go for another solution. See, the same thing I am doing in case of tic-tac-toe. I am always thinking, if I give my cross in this position, whether it will be create a straight line or not. Then I will go for backtrack, another route. So this type of algorithm is backtracking, called backtracking. Okay, so normally these are the 6 different types of algorithms based on how we are solving the problem, how we are going to the solution. We have 6 different types of algorithm. Number 1 is brute force, where we are using each and every element to decide the solution. Then we have divide and conquer, where we are not using all the elements, we are bypassing some elements to solve the problem. Then another alternative of this divide and conquer is dynamic programming. The basic difference is, in case of divide and conquer, the sub-problems having no dependency, but in case of dynamic programming, the sub-problems having some dependency. They will use some past value to solve the problem. There is obviously some recursive solution. Then one interesting type of algorithm which is called greedy algorithm, which is basically used to solve the optimization problem. Okay, and then finally the backtracking algorithm, which is basically used in this type of problems, say chessboard game or tic-tac-toe. In this type of problem, we use this type of backtracking algorithm. Okay, this is all about algorithm. What is algorithm? What are the characteristics? How we can decide whether a particular algorithm is good or bad, and finally, what are the different types of algorithms? Okay, these things you must have to remember when you are solving a particular problem. See, what particular problem can be solved either in brute force or in divide and conquer or in, say, dynamic programming. So you have to try to solve it in different ways. Means these are the different techniques through which you can write your algorithm. Okay, so you should have the basic idea how to write or what is the meaning of this divide and conquer. then you can easily solve the problem in that particular category. Okay, so this is all about algorithms. I'm not going to deep because you have another subject, algorithm analysis, in your most probably in your next semester. So I'm not going to discuss too much about this algorithm. You will learn more about this algorithms in your next semester class. Now I will discuss something about this data structure. So since we are going to implement this data structure and algorithm both in C language, so this is one prerequisite for your this particular class. You should have idea about C language, and you have already done C language in your previous semester. And if you want to learn more, you can go to my YouTube channel, where you will see the online classes on coding, where I have discussed the basic idea of C language and then some advanced idea of C language. You can go and learn those things. And before ending today's class, I want to discuss something about this data structure. You see, when I have implemented or I have installed some C compiler, so suppose I have installed some C compiler in my device, then remember my RAM will be divided into some parts. Okay, so if this is my RAM, then from this RAM memory, some portion will be used, suppose up to this will be used for C language. Whatever program you will write, this part of the memory will be used for performing your C language program. And this memory will be divided into these types. Remember, the first thing is stack. One type of memory division that is called stack. There is another type of division which is called heap. Okay, there is another type of division which is called constant. There is another type of division which is called static. Okay, there is another type of division which is for text. Okay, so these are the total division of your C memory, C language memory in your RAM. Okay, so all your variables, local variables, okay, then array, all will be stored in the stack memory. This heap memory will be used for dynamic memory allocation. I hope you have heard this dynamic memory allocation, malloc-talloc. This heap memory will be utilized. Now, sometimes we require some constant variables, so those will be stored into this part, constant memory part. Sometimes we require some static variables, so those will be stored into this part. And I will write some code. I will write some code, int main, then printf, scanf. So this is in a form of text that will be stored into this part. So this is the overall division of your C memory, where when you will write something, that will be stored in this parts. See, everything is done in RAM. When you will save it with some .c extension, then it will move into your hard disk, and it will create 4 types of files. One is .c, another is .obj, then another is exe.exe, another is backup file. So 4 types of file will be created for a particular C file. 4 different types of files will be created, and this will be stored in your hard disk. But whatever you are writing, when you are running your code, everything is done in your RAM. Okay, and how your RAM is utilizing the C memory, these are the different parts or sections of memory that will be utilized in your RAM. Some part is called stack, some part is called heap, some part of the memory is called constant, some part of the memory is called static, and this text is used to store whatever you are writing. Whatever code you are writing, that will be stored into this part of the memory. Okay, so this is the overall memory division of your C language. Okay,